On the evening of August 21, 1986, Lake Nyos looked ordinary. The crater lake in northwestern Cameroon was quiet. Farms and villages occupied the valleys below it. There was no advancing storm, no wall of lava, and no warning broadcast. Then, sometime after dark, the lake released something that could not be seen. People in the surrounding settlements heard a deep sound. Some described it as an explosion or a rumble. A white cloud or mist appeared near the water. Then the valleys went silent. By morning, entire households had stopped moving. Livestock lay where they had been tethered. Cooking fires had gone cold. In the affected area, birds, insects, and other animals had also died. Yet buildings remained standing. Trees were not burned. There was no layer of ash, no flood deposit, and no obvious wound on many of the victims. Some people awakened after hours of unconsciousness. Others returned to villages and found almost no one alive. At least 1,700 people died, along with thousands of cattle and other animals. The disaster reached the settlements of Nyos, Subum, Cha, and the low ground connecting them. Whatever had left the lake had followed the valleys. The first question was simple: what could kill on that scale without destroying anything around it? Lake Nyos sits inside a volcanic crater, or maar, created by an explosive event in the geologically recent past. Beneath it, carbon dioxide from deep magmatic sources migrates upward through rock and groundwater. But investigators found no evidence that a conventional volcanic eruption had occurred on the night of the disaster. The danger was already inside the water. To understand it, imagine opening a bottle of carbonated drink. Under pressure, carbon dioxide remains dissolved in the liquid. Remove the cap, reduce the pressure, and bubbles rapidly appear. Lake Nyos behaved like an enormous natural bottle, but one almost 200 meters deep. Cold water at the bottom of the lake could hold far more dissolved gas than the warm water near the surface. Because tropical temperatures change relatively little through the year, the lake did not completely mix in the way many temperate lakes do. Dense bottom water remained trapped, receiving a slow supply of carbon dioxide from below. Over years, the deepest layer became increasingly charged with gas. The pressure of the water above it kept that gas dissolved. Then something disturbed the balance. The exact trigger has never been established. A landslide entering the lake has often been suggested. Cooling, heavy rainfall, internal movement of the water, or another disturbance may also have played a role. The official scientific investigation could identify the stored gas and the mechanism of release, but not the single event that began it. Once a parcel of gas-rich deep water started rising, the pressure around it decreased. Carbon dioxide came out of solution as bubbles. Those bubbles made the water lighter, causing it to rise faster. Faster rising produced more bubbles. The process fed itself. What began below the surface became a runaway eruption of gas and water. Investigators found evidence that the lake had violently overturned. Vegetation near part of the shore had been flattened. A wave had washed across the lake margin. The normally blue water had turned reddish-brown as iron-rich deep water reached the surface and oxidized in the air. But the greatest hazard was not the wave. The released carbon dioxide formed a dense cloud. Carbon dioxide is heavier than ordinary air, so instead of dispersing upward immediately, it poured over the crater rim and moved downhill. It traveled through valleys and collected in low places, the same places where homes, animals, and sleeping people were concentrated. The cloud displaced breathable air. At very high concentrations, carbon dioxide can cause confusion and loss of consciousness within moments. Victims could not simply smell danger and run. The gas is colorless, and at the concentrations involved it could disable a person rapidly. Ordinary filter masks would not provide oxygen. Many survivors developed skin injuries. Early rumors treated them as burns from volcanic acid or heat. Medical investigators concluded that many were pressure injuries caused by lying unconscious in the same position for long periods. The pattern of survival also revealed how the cloud behaved. High ground offered protection. Some people inside the affected region survived because they were above the densest gas, because air entered their shelter, or because the cloud had thinned before reaching them. In depressions, the concentration remained lethal. Lake Nyos was not the first warning. 2 years earlier, in August 1984, a gas release at Lake Monoun, another Cameroonian crater lake, had killed 37 people. At the time, the event was so unusual that its cause was disputed. After Nyos, the connection became impossible to ignore. Of the crater lakes examined in the region, Nyos and Monoun contain significant quantities of dissolved carbon dioxide. The Nyos investigation produced another frightening conclusion. The disaster had not emptied the lake of danger. Carbon dioxide was still entering the bottom water, and substantial concentrations remained dissolved there. If nothing changed, the lake could recharge. Scientists proposed releasing the gas gradually, before it could accumulate to catastrophic levels. The solution used the same runaway process that made the lake dangerous. Engineers installed a pipe reaching from the surface into the deep, gas-rich water. Water was initially pumped upward. As pressure decreased inside the pipe, carbon dioxide formed bubbles. The expanding gas lifted more water, creating a self-sustaining fountain. Once started, the system required little additional energy. Instead of one massive release, the lake could breathe through controlled pipes. Degassing began with an experimental installation and later expanded. The fountains became a visible sign of a danger that had once been completely hidden. Monitoring, additional pipes, and work on the lake's weak natural dam became part of the long-term effort to protect nearby communities. Lake Nyos changed the way scientists understand volcanic lakes. It showed that a lake can store an enormous quantity of gas without obvious surface activity, and that topography can turn an invisible release into a moving natural disaster. It also leaves an uncomfortable uncertainty. Scientists can explain where the carbon dioxide came from, how it accumulated, why it erupted from solution, and how the lethal cloud traveled. But the precise trigger on August 21, 1986, remains unknown. The lake did not erupt like a volcano. It did not poison the region with a mysterious chemical weapon. It released a gas that exists naturally in every breath we exhale. For years, that gas had collected silently beneath calm water. Then, in a single night, the lake turned itself inside out.